Tonight, you'll have heard from many amazing scientists. You'll have heard what great innovations the future will hold. You won't hear that from me, because instead, I'm going to talk about the past. Because what we're going to answer over the next 3 minutes is, can you hear the Big Bang? Hi, I'm Samuel Hinton, and I'm at the University of Queensland, and let's get into the details. You may have heard that in space, no one can hear you scream. And it's true. It's true for space now, but it's not true for space back when we care about, back just after the Big Bang. You may know that the universe is expanding. And if you think about all the matter in space, it's spread out over this vast cosmic distance. But let's stop and rewind the clock. If we go from a universe that's expanding and go back in time, suddenly it starts shrinking. And all it takes is a universe small enough. And space no longer looks like space. It looks like Earth's atmosphere, thick and dense. If you keep going even smaller, it changes again, and space suddenly starts looking like the sun, a fiery ball of plasma, soup, energy, and matter. In the primordial fluctuations just after the Big Bang, quantum mechanics, aka magic, says that some parts of the universe have just a little bit more mass than other parts. Now, because the universe was a fluid way back then when it was super small, that means that those overdensities can spread out. It's like sound waves in space, like popping a balloon that you put extra air in, like ripples on a lake. Now, as the universe keeps expanding, these ripples expand along with it too. They're traveling just like sound waves until they get to a point where the universe has now gotten large enough that space doesn't look like a fluid, it looks like space as we know it. And suddenly these acoustic waves get frozen in time, like a lake that's snap frozen, all the ripples stay in there. But these ripples, remember, the ripples are over densities. And that means that, well, if you have an overdense piece of the universe, it has more matter in it. More matter means more gravity. More gravity means that more stuff happens, more structure forms, more galaxies and more stars form. So those regions of the universe have more galaxies than other parts. So if we want to hear the remnant of the Big Bang, we can't do it with our ears. We have to use our eyes. By mapping out galaxies in the universe, we can carefully reconstruct those acoustic peaks that I was just talking about. And that's where my work comes in. I model these peaks and create the analysis pipelines to make sure that we can actually do the science in a finite amount of time. Stuff has to get done, and it has to take less than the age of the universe. Now, we do all this stuff because those acoustic peaks tell us great information about dark energy and dark matter, two mysterious components of the universe. Now, unfortunately, I don't have time to delve into what we think they might be. That's an hour-long lecture by itself. But the very, very short story is that we don't know. And that's fairly simple, but we don't know. Hopefully in the next decade we will know, and I promise you that you will be the first to know when we know. Thank you.